everyone! My name is Madeline, and I will be performing the demonstration color-changing lollipops for you today. So I hope you are all super excited to see this demonstration. It's a really cool one with a lot of fun color changes, so I know I'm super excited. So if you have any questions for us today, you can put those in the question and answer tab. And those will be answered by our management team, who are working with the Zoom behind the screens. And then we'll also have some poll questions throughout the demonstration today, just to see how you're understanding the content. So those will be asked by my team member, Selena, who will be reading those out and helping you answer those poll questions. So thank you very much, and I'm really looking forward to starting this demonstration today. Also, before we start the demonstration, it's really important that we say a disclaimer. So the disclaimer is that I'm a trained scientist, so I have all of the knowledge as well as personal protective equipment, including my safety goggles, my lab coat, and some gloves. Please ensure I will be safe throughout the demonstration. So please do not try this at home. Additionally, our demonstration involves the use of lollipops. However, after the demonstration, these are not safe to consume. So these are just used because of the ingredients they contain, and they will be a good demonstration of how there is chemistry all around us in the world. So without any further ado, let's get started. So the reaction I'm going to be modeling today is a special kind of reaction, and it's called a redox reaction. So in a redox reaction, what is different about it is, you know, in a reaction how atoms move around. So in a regular chemical reaction, atoms will form new shapes and new bonds with other atoms in the reaction. However, in a redox reaction, this happens, but another thing also moves, and those are electrons. So electrons are really small, negatively charged particles, and those will move around in a redox reaction as well. A really common example of a redox reaction is the battery. So you might have used a tablet or a phone, and you might be watching this Zoom on a device right now. So those are all charged and powered by batteries, which do redox reactions to provide electrons and create the electricity. So just to get things started, we're going to start with a first poll question. So I'm going to let Selena take over with that one.
So our question is, what is exchanged in a redox reaction? A, electrons, B, atoms, or C, all of the above?
We have about 30 seconds left on that poll. And it looks like right now all of the above is winning, with electrons in a close second. Okay, so it looks like the results of those polls have been shared. And yeah, looks like the majority is right. So the answer is all of the above. So electrons and atoms move around. So now that we have a bit of an idea of what a redox reaction is, let's get started with this redox reaction. So what I have here today is a beaker filled with water. I also have some sodium hydroxide, which is a strong base that we'll use in the reaction. And I have these lollipops. And these lollipops contain the sugar glucose, which is going to be really important for our reaction today. So let's get started. I'm going to measure out some of this sodium hydroxide base. I'm going to put about 30 milliliters. All right, and I'm going to add this to our beaker. Next, I'm going to add about 170 milliliters of water. So that'll make the total volume in here about 200 milliliters. And I'll add that using the smaller. all the things we need to get our reaction started. And I'll explain what all of these chemicals are doing once everything has been added and the reaction begins. So now we have about 200 milliliters of mixture in here, and now it's time to add my potassium permanganate. So this is a purple colored solid that will help us see all of our color changes throughout the reaction today. Now I'm going to add a very small amount of this, because if I add too much, the color will become too dark, and it'll be too difficult to see. So I'm just going to add a very small amount. Alright, so that looks good to me, and I'm going to give this a stir so we'll be able to see the nice purple color. And then as you can see, this has changed to a nice purple color. And if I keep stirring this, it's not going to change color. So there isn't really a reaction that's changing color happening between the base and the potassium permanganate. That's just going to stay purple throughout this reaction. So that's where our glucose comes in. So I'm going to take this lollipop, and we're going to unwrap it. This is a purple lollipop, so, the lollipop may not influence the color of the reaction. And I'm going to slowly stir this. Now, as I stir it, I want you to pay really close attention to the color of this. And I'll move this a little bit closer so you can see. So, actually move a little bit back so you can see better. So, as we stir this, we're going to pay very close attention. And there's going to be a color change that happens pretty quickly. So the first color change is going to become kind of like a dark blue. Then you'll hopefully see a green color, a yellow color, and maybe even an orange color. So let's get started and give it a try. So as I slowly stir, the reaction will start to take place. So now this is becoming a bit of a darker color if I stop stirring it, and you can see it looks a little bit more like a bluish purple color. Now you can start to see it lighten. It's becoming a little bit more of a green color. So now this is solidly a green color. You might not be able to see it too well on camera, so I'll turn it a little bit in the light. And maybe you can see this has definitely changed color from where we started. So I'm going to keep stirring. Now some of these color changes take a little bit longer to happen because we need all of the molecules in the solution to react. And then we need another reaction to take place. So these reactions all take time. They're all atoms bumping into each other. But you can start to see this start to lighten. So maybe you can see this is becoming a bit of a lighter green. I'm going to keep stirring it. This continues to get lighter. Now it's kind of like a yellowish green. Now this has become quite yellow. And it becomes even darker, almost an orangey color. I'll keep stirring, but this is very close to the end of our reaction. So as you can see, we went all the way from a purple color at the start that was quite bright to now this yellowy orange color. So clearly a lot has happened in this reaction. Let's start to break down what happened. So first, I started by adding the sodium hydroxide base to the water and the potassium permanganate. As you saw, this was just a purple color, and no redox reaction was happening. But when I added the sugar, there started to be a reaction. So I want to ask you a poll question at this time. So I'll let Selena take over for that one.
So our next question is, what part of the demonstration is responsible for the color changes we see? A, the lollipop, B, sodium hydroxide base, C, potassium permanganate, or D, water?
So right now it looks like the lollipop and the sodium hydroxide base are winning. Make sure to put in your answers. Alright, and it looks like the lollipop has won. So that's a really good guess. You might think the lollipop is what's directly responsible for the color changes, because when we added it, that's when things started to change and we started to get all these color changes. However, it's actually this potassium permanganate that's responsible for the color changes. So the potassium permanganate is a special kind of metal, and it can take a lot of different forms. And so when we add the base with the lollipop, something starts to happen. The base will start to give electrons, which are those small negative charges to the sugar. So as the base gives these electrons to the sugar starts to pass them on to the potassium permanganate. And the permanganate can have a lot of different forms. It's a type of metal called a transition metal. So it can take a lot of different shapes and do a lot of different reactions. So first, the potassium permanganate will change into a form called manganate. So this manganate has one more electron than the permanganate. And this one more electron makes it kind of a green color. Next, the manganate will turn into manganese dioxide. And that's what's responsible for this orangey color we see here. So it's basically just electrons being added and oxygens being removed that cause these color changes. And that's the redox reaction that's happening here. I have another question for you now.
So our next question is, why is it important to add the base to the water at the start of the reaction? A, to melt the lollipop. B, you can skip the step. C, because you ran out of water. Or D, to provide a source of electrons for the sugar.
Okay, it looks like at this time, the source of electrons for the sugars are winning. Some people think we can skip this step. Make sure to lock in your answers soon. Alright, so really well done everyone. So the base provides a source of electrons for the sugars. So sodium hydroxide is a strong base, and this means it's really good at giving electrons to other atoms in the solution. So it starts to react with this sugar, and then the sugar will pass electrons to the potassium permanganate, causing all those color changes that we saw. But why do these color changes happen? Well, let's go through a brief background on color. So color is basically a relationship between absorption and reflection of light. So you might have heard that white light is actually all of the colors of light being reflected. And then the color black is actually a result of all of the colors being absorbed. So basically, when we start to do this reaction and electrons move around, this causes the shape of the molecules to change. They start to orient themselves a little bit differently because now they have more negative charge. So when they have more negative charge, they start to take on these different shapes that cause a color change. And this happens all the way until we get to the manganese dioxide. Once we get here, there will not really be any further reaction, but we could keep stirring it for longer and maybe get more concentrated orange color. So therefore, our reaction is we mix a base with sugar and potassium permanganate. This causes a bunch of electrons to be introduced that cause changes in the permanganate. And this results in color changes because it affects the absorption and reflection of light. There's a lot of cool science that goes into this. A really cool application of this is actually how your body uses sugar, which is why it's cool that we use sugar in our demonstration today. Your body uses similar redox reactions to get energy out of sugar that gives you energy to run around and do anything you enjoy. Thank you so much for listening today, and that is all for my demonstration. I would be happy to answer any of your questions in the question and answer tab. Be sure to check out the rest of our demonstrations throughout today too. Thank you.
Perfect. So we have the first question here from the chat. This person is asking, according to Google, Redox is oxidation changes in atoms as electrons are exchanged. And they want to know, so that I think this pertains to the first poll question you did, so they want to know how then are the atoms moving around?
Yeah, so that's totally right. So electrons are moving around, but in redox reactions, typically new products are formed as well. So that also results in, atoms moving around. So for example, when we made manganese dioxide, from starting the permanganate, that had 4 oxygen atoms. But manganese dioxide only has 2. So when you move electrons around, sometimes you also have to move atoms, because that allows you to transfer that charge in a way that makes a nice stable product. And in this case, we see a color change associated with that.
Awesome. Another question here is, what were the chemicals used in the first reaction? And they want to know, is this a litmus type reaction that is like a change in pH?
So in this reaction, there isn't a change in pH. So when you add the base, there would be a change in pH, but the rest of the reaction, so combining the sugar and the permanganate, does not result in a change in pH. And I think I missed the first part of the question, sorry.
What were the chemicals used in the first reaction?
Oh yes, so the chemicals used are potassium permanganate. So that gives us the purple color that turns into the green color and the yellowy orange color. And then sodium hydroxide, which is the strong base that donates those electrons. Then we just have water, which is just kind of a solution, so we can see all of these color changes happen. And the lollipop, which contains glucose, which is going to be what helps to transfer those electrons.
Awesome. And kind of related to that question, another person is asking, what elements make up potassium permanganate?
Yeah, so potassium permanganate is made up of a potassium. Then it has a manganese, which is that special transition metal. And then there are 4 oxygen atoms. And like I mentioned, those oxygen atoms will start to change as you add those negative charges. So in the manganate, you have still 4, but more electrons. And in the manganese dioxide, which is the final product, you just have manganese and 2 oxygen atoms.
Perfect. We have one last question here. Aiden wants to know, so if your body gets energy out of sugar, is that why food has sugar in it?
Yeah, exactly. So sugar is actually a really important source of energy for your body, because your body can easily break it down through these redox reactions. So it's sort of a similar reaction. We don't have any potassium permanganate in us, but that gives a much funner color change for you to see than the regular reactions that we have going on in our cells.
Perfect. That looks like all our questions for today's presentation.
Awesome. Thank you so much. Really happy to answer those questions. Yeah, so thank you so much for asking questions and for paying attention to our demonstration today. I really hope you enjoyed and learned a little bit about redox reactions and about potassium permanganate and color changes. So that's all for me today. I really appreciate your attention, and bye for now.